Hi guys, so today our topic will still be about exponential equations, exponential functions, and exponential inequalities. So please listen carefully and pull up your notes and pen. Our objective is for you to represent an exponential function through its table of values, through its graph, equation, and you should be able to find the domain and range, its intercepts, zeros, and asymptotes. And for our learning competencies, the learner should be able to represent an exponential function through its table of values, graph, and equation. You should also be able to determine the intercepts, zeros, and asymptotes. And you should be able to solve problems involving exponential functions, equations, and inequalities. So let us recall exponential functions. Exponential functions are functions in the form of f of x equals a times b raised to x, where b is greater than 0 and not equal to 1, because if so, then our function will not be an exponential function, it will be a constant function. And also a should not be equal to 0 since our function will be equal to 0. So for our restrictions, since b should not be equal to 1, then we can assume that b is equal to r plus 1, where r is our growth rate per unit of time as a decimal. So sa exponential functions, we have two restrictions. If b is greater than 1, then r is greater than 0. So that function represents exponential growth. While if b is greater than 0 but less than 1, then our growth rate per unit is less than 0, thus represents exponential decay. I believe I already discussed how we can find the value of x in exponential functions, so let us now proceed in graphing exponential functions. So before graphing the exponential functions, we should be able to identify whether it is an exponential growth or exponential decay. So last week I already discussed how we can say if an exponential function is growing or decaying. So we should look for the value of the base. If the base is greater than 1, then we can assume that it is an exponential growth. While if the value of the base is greater than 0 but less than 1, then it is an exponential decay. So after that we have identified if it is growing or decaying, step 1, we construct a table of values of ordered pairs for the given exponential function. So the range is dependent. We can use -5 to 5, -3 to 3, whichever you like. And after that, we proceed to step 2. We plot the points and connect them using soft curve. For example, sketch the graph of f of x equals 2 raised to x. So first, we should identify if the exponential function given is an exponential growth or an exponential decay. So we just have to get the value of the base, which is 2. Then 2 is greater than 1. So we can say that our function is an exponential growth. So we expect higher value or increasing value for the f of x. So now we proceed to step 1, which is filling out the table of values. So we have two columns here, x and f of x. So for x, the values are starting from -3 to 3. Then we just have to substitute it on our exponential function to arrive with the values of f of x. So notice from the table that the output values are positive for all values of x. Yes, we can clearly see on the table that regardless of the value of x, we have here negative values, positive values, the output are still positive. So next, as x increases, the output values increase without bound. Yes, we can clearly see that. So from negative 3 to 3, we can see that the values of f of x are also increasing from 1/8, 1/4, 1/2, 1, 2, and 4, and 8. So next, as x decreases, the output values grow smaller, approaching 0. So when our x decreases, our values on f of x decreases, approaching to 0, but will never touch 0. So after we have finished our table of values, we need to plot them, and we can clearly see on our right side how it looks like. So it can be observed that the function is defined for all values of x. It is also strictly increasing, yes it is, and attains only positive y values. Yep, as we said earlier, kahit ano yung value ng x, yung f of x natin or yung y natin, still increases. So, next, as x decreases without bound, the function approaches to 0. So, habang pababa naman ng pababa yung value ng x natin, yung f of x is approaching 0, but it will never touch 0. So, we can say that the horizontal asymptote for this function is line y equals to 0. So, yan. This trend is also known as exponential growth. So for the next example, sketch the graph of f of x equals 1/2 raised to x. So we get the value of the base, we have 1/2. So we can now identify whether it's an exponential growth or exponential decay. So since the value of the base is 1/2, which is greater than 0 but less than 1, then our exponential function is considered an exponential decay. So now we proceed to the table of values. Yes, we also use negative 3 to 3 here. But on the values of f of x, we can now see that the values are decreasing. So notice from the table that the output values are positive for all values of x. Yes, it is still positive, but as x increases, the output values grow smaller, approaching 0. So habang tumataas ng tumataas yung values ng x natin, pababa naman ng pababa yung values ng y or ng f of x, approaching to 0 naman. And on the other side, habang pababa naman ng pababa yung value ng x, the output values grow without bound. So habang bumababa naman yung values ng x hanggang nagiging negative siya, palaki naman ng palaki yung value ng y natin. So now let us proceed in graphing. So yung mga values ng x and f of x natin, we just have to plot it, and on our right side, we can now see how our function looks like. So makikita natin pababa yung slope niya, pababa. So it can be observed that the function is defined for all values of x. It is also strictly decreasing and attains only positive values. So as x increases without bound, the function approaches, and still the horizontal asymptote is y equals to 0. So this trend is also called exponential decay. So after learning how to graph, we now proceed in finding the intercept and asymptotes of exponential functions. So first we have intercept, the points of intersection of the graph to the axis. and we have x and y-intercept. So x-intercept, the point where the graph crosses the x-axis. So to find x-intercept, we just need to set y equals to 0. And next, for y-intercept, this is the point where the graph crosses the y-axis. And we just need to set x equals to 0. So for example, solve for the intercepts of g of x equals 5 raised to x minus 125. So in finding the x-intercept, we set y to 0. So for our equation g of x equals 5 raised to x minus 125, we don't have y yet. So we replace g of x with y. So we have y equals 5 raised to x minus 125. Then the next step, we let y equals to 0. So we now have 0 equals 5 raised to x minus 125. And then we now solve for x. Simplifying the equation, then we get the value of x, which is 3. So our x-intercept is coordinates 3, 0. So for the y-intercept, simply set x to 0. So we just also need to replace g of x with y. Then we have y equals 5 raised to x minus 125. Then we now let x equals to 0. Then we have y equals 5 raised to 0 minus 125. Then now we solve for y. Then we arrive with the value of y, which is negative 124. Therefore, our y-intercept is coordinates 0, negative 124. Another example, solve for the intercepts of f of x equals 3 raised to quantity x plus 2 minus 9. So for the x-intercept, first we replace f of x with y. So our working equation now is y equals 3 raised to quantity x plus 2 minus 9. Then we let y equal to 0. So we have 0 equals 3 raised to x plus 2 minus 9. So now we just solve for x, simplifying the equation, then we arrive with the value of x, which is 0. So our x-intercept is 0, 0. So for the y-intercept, yes, we just replace f of x with y. Then we let x equals to 0. So we have y equals 3 raised to 0 plus 2 minus 9. Then we solve for y, simplifying the equation, we arrive with y equals to 0. So the y-intercept is also 0, 0. So after the intercepts, we have asymptote. Asymptote is a boundary line which the graph of the function approaches but not touches. So for exponential functions, it only has horizontal asymptote. So exponential function of the form f of x equals a times b raised to x minus c plus d has horizontal asymptote at the line y equals to d. If there is no d, then the horizontal asymptote is y equals to 0. For example, solve for the horizontal asymptotes of the following. So, for y equals 3 raised to x plus 2 minus 9, so our horizontal asymptote is just y equals to negative 9. So, for y equals 3 raised to x plus 3 plus 2, our horizontal asymptote is y equals to 2. So, for y equals negative 2 raised to x plus 2, since wala siyang on the form of a b raised to x plus c, wala siyang value of c, then we say that the horizontal asymptote for this function is 0. So, dito naman sa baba, nauna naman yung translation. 3 plus 2 raised to x minus y. So, regardless saan man nakalagay yun, still our horizontal asymptote is equal to 3. And for the last, we have y over 2 minus 1 equals 4 raised to x minus 1. So una, we just have to make y as independent variable without any constant in it. So we just have to multiply 2 to cancel out the value. So after that, we have now 2 times 4 raised to x minus 1 plus 2. So our horizontal asymptote is equal to 2. So next we have the domain and range of exponential function. So the domain of an exponential function is always the set of real numbers, meaning no matter what number you substitute to the value of x, you will always be able to evaluate the function and you will arrive to a certain value. So the domain is from negative infinity to positive infinity for all exponential function. So for the range of exponential function, in the form of f of x equals k times a raised to x plus c, we will take note of the value of k and the value of c. Since if k is positive, then the range is y greater than c because the points of the graph will appear above the asymptote. And if k is negative, then the range is y less than the c because the points of the graph will appear below the asymptote. So for example, solve for the domain and range of the following. So for f of x equals 3 times 8 over 9 raised to x. So for in finding the domain, since there is no restriction, the domain is always the set of real numbers. So our domain is the values of x such that x is an element of real numbers. So for the range, since our k is 3 and our c is 0, dahil wala naman siyang plus c, wala namang value, so our range is greater than 0. So the range are the values of y, wherein y is greater than 0. And for another example, we have f of x equals negative 3 times 8 over 9 raised to x. So yes, again for the domain, we have the values of x such that x is the set of real numbers, while for the range, since our k is negative 3 and our c, we don't have plus c, so our range should be less than 0. So range are the values of y such that y is less than 0. So guys, that's all for me today. I hope you learned something new, and if ever there are clarifications, concerns, you can just send me a personal message. So have a great day and good luck.